Good day, superstars. I won't be seeing you today because it's Women's Day, and I hope you enjoy this break from the normal school routine. Today, we're going to have a look at hypotheses and types of data. So, diving deep into the scientific method, we think about what science is. Science observes the natural world around us to explain events in the natural world and make useful predictions. Science deals only with the natural world. And as a scientist, we have to explain these observations. I want you to pause the recording for a while and then go outside, look around you, observe the natural world, and come back with an interesting scientific question. So to make useful observations is really important in science. Gathering information about events or process in a careful, orderly way. Once we make observations, we will be able to record data. In science, there's two important types of data. Firstly, quantitative data. This is numbers or values that can be counted or measured. For instance, volume, temperature, pressure, speed, amount of organisms, height of growth, all examples of quantitative data. Qualitative data are descriptions and involve characteristics that cannot be counted. These are emotions, attitudes, and behaviors. Let's apply this knowledge. What would the quantitative data for the cat be? Think about this. Write down at least 2 or 3 characteristics that can be explained as quantitative data. Correct. We can count the legs of the cat. We can measure the height of the cat. And we can also measure the length of the tail. These are all values that can be counted or measured with specific apparatus. Qualitative data is the behaviors. Let's see, a friendly cat or an agitated cat. A cat that finds strangers as enemies. These are all examples of qualitative data. The next important bit is the hypotheses. Hypothesis sounds like a very difficult scientific term, but actually it's just an explanation for our observations. So the scientific method starts with hypotheses. It's a possible answer to that question you asked yourself after you observed some natural phenomena outside. It must be thoroughly tested. When you think about hypotheses, you have to include your dependent variable and your independent variable. We spoke about this last week. So let's recap on an independent variable. An independent variable is the variable that you, the scientist, decide to change in order to see the dependence of the dependent variable. We're going to look at a few examples. A good scientific question. How does the size of a dog affect how much food it eats? A possible hypothesis would be that larger animals of the same species expend more energy than smaller animals of the same type. To get the energy their bodies need, the larger animals will eat more food. Think about this hypothesis. Do you think we're going to gather qualitative data or quantitative data? Correct. It's quantitative data because we can measure the weight and the size of the animals, like you can see in the prediction. The next question does fertilizer make a plant grow bigger? Plants need many types of nutrients to grow. Fertilizer adds the nutrients to the soil and thus allowing the plants to grow more. Is this qualitative or quantitative data that we are going to gather? Correct. Also quantitative because we can measure the amount of fertilizer we add to the soil, and then we can measure the height or the amount of fruit produced by different types of plants in the same type of soil, in the same environment, same temperature, same amount of sunlight. Does an electric motor run faster if you increase the current? Hypotheses. Electric motors work because they have electromagnets inside them. These magnets push or pull the permanent magnets and make the motor spin. As more current flows through the motor's electromagnet, the strength of the magnetic field increases, thus turning the motor faster. Let's think about this hypothesis for a moment and identify the independent variable. What is the scientist going to change in this investigation? The scientist is going to change the amount of current that flows through the motor. If this is the case, then current must be our independent variable. What in this investigation will be dependent on the current that flows through the motor? That would be how fast the motor turns, or, as we can see in our predictions, the round per minute or revolutions per minute of the motor. That would be our dependent variable. Is this type of data quantitative or qualitative? Quantitative. We can measure with an ammeter the amount of current, and then we could count the revolutions per minute of the motor. Is a classroom noisier when the teacher leaves the room? Teachers have rules about when to talk in the classroom. If they leave the classroom, the students feel free to break the rules and talk more, making the room more noisier. Would this be quantitative or qualitative data? Let's see if you were correct. Qualitative data. Although we can measure the noise of the room with a decibel meter, we can also just observe the behavior of students and measure the qualitative data regarding the behavior of the students. Let's recap. In science, we make observations. We have to be able to gather data and explain these observations in an orderly manner. We get either qualitative data or quantitative data. Quantitative data can be counted or measured. Qualitative data will only be observed. It is important to remember that your hypothesis will be the answer or possible answer to your scientific question. It's important to remember that in your hypothesis, you have to add your independent variable, which is the variable that you choose to change in your investigation, to see how this variable affects the dependent variable. So this is our lesson for Monday. Hope you've enjoyed it. Please remember to do your assignments for today. Don't procrastinate, and I'll be seeing you on Tuesday. Have a super day.